Hey guys, we're going to look at inverse relations and functions. It's kind of an easy concept. Basically, what we're saying is if I have a function that gives me an ordered pair x, y, then the inverse would be the opposite. It's going to give me an ordered pair y, comma, x. We have flipped the coordinates. So let's look at some inverse functions here. I have f of x equals this x minus 5, and I'm telling you that its inverse is x plus 5, the inverse of that function. So let's look at it and see. Well, this says if I plug in a 7 for x, I get out a 2. So in order for this to be the inverse, we're saying if I plug in a 7, I get out a 2. And I just told you it's the flip-flop then for the inverse. So if I plug in a 2, I should get out a 7. If I plug in a 2 for x, 2 plus 5 is 7. Let's try it with another one. Let's say f of 4. Well, f of 4 would be 4 minus 5. 4 minus 5 is negative 1. So f of 4 equals negative 1. I plugged in a 4. I get out negative 1. So for the inverse function, if I plug in a negative 1, I should get out a 4. So let's try it. The inverse function is going to be negative 1 plus 5, which is in fact 4. So it worked. If I plugged in a negative 1 for x, I got out a 4. So let's look at what this image would look like on the graph. So we're going to plot the ordered pairs 2, 4. I'm going to pause the video and plot this real quick. And voila, there it is. So the inverse would then be 4, comma 2, 2, negative 3, and 1, 4. So now let's plot those in blue. And voila, there it is. So these are inverse relations. And kind of look at this and think about what's happened. It kind of looks like maybe it's been rotated or maybe there's some sort of flip that happened. I want you thinking about what is possibly happening here with the function and its inverse. All right, so let's try another one. This one's a little bit different. This time we're not given ordered pairs, we're given a function. Y equals 3x plus 2, or f of x equals 3x plus 2. So the way that we go about finding its inverse, logically reasoning, if we set up here that we change it from x to comma y to y comma x, what we can do then is interchange our x and y coordinates, and then I want to solve for y to get the inverse relation. So this is my f of x. So the inverse of x is found by switching these coordinates places and then solving for the y. So I have x minus 2 equals 3y. Divide both sides by 3, and I get y equals 1/3 x minus 2. And I had originally y equals 3x plus 2. So my function, my f of x, was the first function, and the inverse of f of x is the second function that I have. So let's plot these on the graph. Okay, so I've plotted the points. I didn't draw the lines because I wanted to show you a trick I learned this week. If you hold the shift button down and then draw your line through the points while holding the shift button down, it makes a beautiful line. Isn't that nice? So let's try it again. And there it is. There is our function in the blue and its inverse in the dark purple on the graph. Okay, so let's try another one. I encourage you to pause the video and see if you can do this yourself. I'm going to go ahead and pause the video and plot this function in purple, and then I will resume the video and we will find the inverse of this function. All right, so let's find this inverse. I rewrote the function and interchanged my x and y. Now I'm going to solve. So I have x minus 1 equals a negative 1/2 y. So to get rid of this negative 1/2, we know to multiply by the reciprocal. If I do it on one side, I have to do it on the other. Be sure to distribute to both terms. Negative 2x plus 2 equals y. So now we can plot this. So I start at positive 2. I go down 2 over 1, down 2 over 1, down 2 over 1. Or I could go this way, up 2 over 1, up 2 over 1. Has a negative slope. Okay, and there it is, graphed. Again, think about, what does this look like? What does it look like is happening in these functions as we do this? Well, I'll give you a little hint. If I draw a line in here, I want to draw this line in orange. Boom, boom, boom. These lines are being reflected across this line y equals x. So again, let's do the line y equals x, down 1 over 1. Just do it this way. Boom, 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 boom. There it is. There's a reflection happening. I don't know if I drew that line exactly straight, but you get the idea. And here again, it passes through the origin, and it has a slope of up 1 over 1. So these images are being reflected across the line y equals x. And that makes sense because we're saying we're flipping those x's and y's places. So x equals y equals x, we flip them. And so that is why this image then is being rotated across the line y equals x. We had a spoiler alert to this in class, so I went ahead and put it in there. That was pretty awesome that someone was able to figure that out just by looking at it. So, or, I mean, logically reasoning, we should be able to figure that out since I'm switching, again, the x and y coordinate places. X's and y's, I'm switching them places, then of course it's being reflected across the line y equals x. All right, so this was a little bit more complex. We're going to find the inverse of this function. So we have y equals x squared plus 2x plus 4. So if I want to find the inverse of f, what I'm going to do is again switch them places. So x equals y squared plus 2 times y, that's not a y, plus 4. Okay, so I'm going to move this 4 over to the other side. And I'm going to try to make this be a perfect square trinomial. Now, if you think back to earlier, we talked about doing this in some of the earlier videos. We take half of the middle term and square it. Well, half of 2 is 1, 1 squared is 1. So I'm going to add 1 here to create this perfect square trinomial so that I can write it as a perfect square trinomial like this. This is the same thing. I just rewrote it. But we got to remember, if I throw this 1 randomly onto this side, then I have to randomly throw a 1 on this other side. It's not so random, is it, when we chose it? So it's the perfect square, but that's okay. So I have x minus 3 is equal to y plus 1 squared. So I take the square root of both sides. So when I do that, I'm running out of room. I'm writing too big. I get y plus 1, I'm just switching sides, equals plus or minus the square root of x minus 3. So to get y by itself, I want to subtract 1 from both sides. So I get negative 1 plus or minus the square root of x minus 3. We looked at these in class graphically, and it creates this parabola. This one is like this up here. And again, it's reflected across the line y equals x, and then we had a parabola that looked like this down here. It's just flipped over. Okay, so at this point, what I would like for you to do is try some of these problems. You don't have to work out all 14 of them, but I would definitely pick at least 2 from each section and make sure that you're getting a feel for it. And I will post answers so that you can check yourself. If you need any help, let me know. I'd be more than happy to help you. Have a great day, guys.